Hi guys, I'm back with another theoretical concept, this time of geometrical optics. In this concept, I'll demonstrate to you that what is the field of view. So, for that, I'm taking an example in which there is a cool boy named as Rocky, and he has topped in his school exams. So his father has gifted him a pair of brand new Adidas shoes. You can see Adidas is written here. This is a Adidas. Okay. Now, Rocky is quite delighted and surprised, and he's trying the shoe, and he wants to see the shoe in mirror while wearing it. So Rocky has done a mistake initially, that he is standing too nearer to the mirror. This is the mirror, and Rocky is standing very closer to the mirror. Okay, now the incident rays, the object is obviously the shoes, because he wants to see the shoes, and the incident ray should reach the eyes of the Rocky so that he could able to see the shoes. Okay, so we when we draw the two incident rays which are falling on the two extremes of the mirror, these 2 points, this one and this one, are the two extremes of the mirror, and when we draw the incident rays falling on these two extremes, this one and this one, so one incident ray is this is coming, and this incident ray is incident normally on the mirror, so it will go back and go back just on its same path. Okay, it will rebound on the same path. Okay, so this is one of the reflected ray. I am naming this ray as R1. Now another incident ray which is falling on the other extreme of the mirror is this, and it is going like that. This is another reflected ray, R2. So these are those reflected ray which are reflected from the two extremes of the mirror. Hence, any of the other ray falling on a region which lie between these two rays, this region, remaining part of the mirror, will go in between these two rays. So, if we consider there are infinite number of rays which are falling on the mirror and are reflected, then there is a complete region which I have shaded like that, this one. There is a complete region in which there would be reflected rays coming from the mirror, whose objects is the shoes of the Rocky. Now, anyone who is in this field of view, this region in fact, which is bounded between these two reflected rays which are coming from the two extreme points of the mirror, is known as field of view. And as its name suggests, anyone who is willing to see the shoes of the Rocky, that means object, so he should be having his eyes in this region, field of view, because we all can see from our eyes only. Now, initially Rocky is standing so much closer to the mirror, so that his eyes, these are his eyes, are not in the field of view. You can see eyes are outside the field of view. So any of the reflected ray coming from the mirror will not be going to the is not going in the eyes of the Rocky. Hence he is not able to view his shoes. Somebody suggested him that he should view the shoes from some distance, far away from the mirror. So he shifted back in the straight line. So you can see that his eyes are now in the field of view, as this field of view is diverging like that. You can see. So his eyes are now in the field of view, and he would be able to see his shoes. Okay, so what is the concept here? What do I mean to say? I mean to say that if any observer wants to see the image of an object in the plane mirror, then he or she should have their eyes in the field of view. Okay, now there is another concept that, let us suppose there is a complete mirror, which is quite a big mirror, which are commonly found in showrooms, and somebody is watching himself in that big mirror, and he is finding himself quite glowing. And this is due to the fact that the area of the mirror which is reflecting the light is big area, and it is quite huge area which is reflecting the light, and therefore much more light is being reflected from the mirror, and the image which is formed by this reflected light would be much more brighter, due to the fact that more and more light is being reflected by the big reflecting area of the mirror. Hence, that person would find himself to be glowing, because more reflected light will be forming the image, and more illuminated or more brighter the image would be. Now, if we destroy that mirror, and if we break that mirror into quite small pieces, and then we pick up one of that piece, and we are willing to see ourselves in that smallest piece, so we might say that we are only able to see our face, therefore our complete image is being not formed in the mirror. And this phrase is absolutely incorrect, and it is wrong, because if we move very far away from that small piece of mirror, a point will come when we will able to see our complete image in that small piece also. So it just means that irrespective of the size of the mirror, the complete image of every object of any size is formed in that mirror. I'm repeating that, irrespective of the size of the mirror, the complete image of every object of any size is formed in that mirror. But that object can be viewed in that mirror or not depends on the fact that are we in its field of view or not. If we are in the complete field of view of that object, then we would able to see that object completely. If we are in the partial field of view of that object, then we will be able to see that object partially. And if we are in completely out of the field of view of that object, then we would not be able to see that object clearly. But that doesn't mean that image is not being formed in that mirror. So irrespective of the size of the plane mirror, complete image is formed of any object which has any size, but there is a difference which distinguish these two sizes of the mirror is the fact that greater is the mirror, bigger is the mirror, greater is the reflecting area of the mirror. Greater reflecting area will reflect greater light, more light, and hence the image which will be forming from the big mirror will be more illuminated and will be more brighter as compared to the image which is being formed in the smaller piece will be less illuminated and will be less brighter due to the fact that the smaller mirror has a smaller surface area which is reflecting the light, and the image formed in that smaller mirror is due to that small light which is being reflected from it. Hence that image would be lesser illuminated and lesser brighter as compared to the image in bigger mirror. So the intensity of light or intensity of image decreases with the size of the mirror, but it is the fact that irrespective of the size of the mirror, a plane mirror always forms the complete image of any object which is kept in front of it, and to view that object we should be in the field of view of that object. Okay guys, so I hope you understand the concept. This is a very important concept as far as geometrical optics is concerned, and there would be many questions based on this concept. I would be taking those questions. Okay, thank you.